Imagine a wire that is alive, buried in mud, stretching for centimeters, carrying electricity to breathe. This sounds like science fiction. It's not. It's a discovery that rewrites how we think life moves energy across the planet. Scientists dug into ordinary seabed and found filaments so thin they look like threads, but up close they are organized chains of cells. Some cells act like tiny anodes, others like cathodes. Together they form a living electrical cable. They call them cable bacteria. At first they were invisible to our expectations. Who imagined bacteria could split metabolic tasks across physical distance, passing electrons from sulfur deep in the dark up to oxygen at the sediment surface? That means cells buried in mud can breathe by sending their electrons along a biological wire to air above. It's like charging a battery with the ocean floor. This created a cascade of surprises. These filaments can span centimeters, enormous for single-celled organisms. They set up electrical gradients that change how sediments behave. They make iron rust differently. They shift nutrient cycles. They even slow down the breakdown of organic carbon. In short, they quietly rewrite the chemistry of the seabed. But the mystery deepens. These are not metal wires. They are living, self-repairing, growing structures. When part of a filament is cut or crushed, neighboring cells reroot and regrow. The whole filament can rebuild itself. It's biology solving an engineering problem with evolution's toolkit. Researchers found them in mangroves, fjords, freshwater lakes, and coastal shelves worldwide. That means this electrical plumbing is not a curiosity in one corner of the planet. It's a global phenomenon with massive ecological consequences. The implications ripple outward. If tiny bacterial wires can shuttle electrons over distances, could similar strategies exist in other hidden ecosystems? Could life on other worlds use electrical plumbing to survive without oxygen? And could engineers learn to tap these living wires for bioelectronic devices or new corrosion-resistant materials? There are even stranger hints. Some cable bacteria seem to manipulate mineral formation, creating bands of iron oxides like tiny architects sculpting the seafloor. Others produce chemical zones that shelter entire communities. These filaments are not passive conduits. They are active directors of an underground world. So next time you imagine the sea floor as empty mud, picture instead a secret grid of living wires humming beneath your feet. A silent, patient network that moves power, shapes chemistry, and keeps whole ecosystems alive. If this blew your mind, imagine what else we haven't noticed. Hit follow for the next secret life unearthed from the deep. Dive deeper with us.